Have you ever wondered how quadcopters are able to move so effortlessly through the air? From hovering in place, to performing its maneuvers. These agile flying machines are powered by some truly fascinating physics principles. In this video, we're going to explore the science behind quadcopters' advanced air mobility and uncover the secrets of their flight. Imagine having the ability to soar through the skies with the grace and agility of a bird, all while being controlled from the ground. Quadcopters have made this dream a reality, thanks to the Bernoulli's principle and Newton's third law of motion. Join me as we dive into the physics behind these flying marvels and discover how they're able to perform incredible feats of aerial maneuvers. First of all, a quadcopter has blades, which are rotated by electric motors. Let us have a look at the blades. The blades of a quadcopter are typically designed with a slight angle or pitch, to optimize their lift and thrust capabilities. This angle is known as the blade pitch, and it refers to the angle at which the blades are tilted relative to the plane of rotation. The blade pitch is typically set such that the leading edge of the blade is angled slightly up, while the trailing edge is angled slightly down. This design helps to create a net upward thrust, as the blades rotate through the air. The blades are tilted in order to take advantage of the Bernoulli's principle, which is a fundamental concept in fluid dynamics. It states that, as the speed of a fluid increases, its pressure decreases. This principle plays a crucial role in the lift generation of a quadcopter's blades. These blades are designed to rotate rapidly, creating a flow of air over them. As the blades move through the air, they cause the air particles to move faster over the upper surface of the blade than over the lower surface. According to Bernoulli's principle, this causes a decrease in air pressure over the upper surface of the blade, relative to the lower surface. This pressure difference creates a net upward force on the blade, which is known as lift. The lift generated by each blade of a quadcopter helps to lift the entire aircraft off the ground and keep it airborne. In addition to Bernoulli's principle, Newton's third law of motion states that, for every action, there is an equal and opposite reaction. As the blades spin, they push air downwards, which creates an upward force on the quadcopter. Therefore, blades of a quadcopter generate lift through a combination of Bernoulli's principle and Newton's third law of motion. The four motors and blades are divided into two sets. One set rotates clockwise while the other set rotates counterclockwise. These blades spin in different directions to cancel out the torque. Torque also affects a quadcopter when its blades spin because each one of them individually creates torque when it rotates. All four torques are added up to determine the total torque acting on the quadcopter. Engineers have come up with a clever way of counteracting this torque. This results in two blades creating torque that acts clockwise and two creating torque that acts counterclockwise. Once airborne, the quadcopter will need to hover. To do that, the upward force needs to match its own weight to achieve equilibrium. In order to roll to the left, the quadcopter increases power to the motors on the right, which increases their thrust, and decreases power on the motors on the left, to reduce their thrust. The result of that force will roll the quadcopter to the left. In order to roll back to the right, the quadcopter simply reverses the process. To pitch forward, the power of the two back motors will increase, and power to the two front motors will reduce. The result of that force will pitch its nose down, and the quadcopter will move forward. To pitch backwards, the quadcopter will simply reverse the process. As viewed from above, the quadcopter will yaw to the left if the power of the motors that rotate clockwise is increased, while the power of the motors rotating counterclockwise is reduced. This will cause the quadcopter to spin counterclockwise around its vertical axis. Conversely, to make the quadcopter yaw to the right, the power of the motors that rotate counterclockwise is increased, while the power of the motors rotating clockwise is reduced. This will cause the quadcopter to spin clockwise around its vertical axis.